We're very happy today to have Fletcher Nichols in today to talk to us about Test Kitchen. Fletcher is the lead developer for Test Kitchen as well as a developer for heavy water operations. So without further ado, welcome.
Thank you. So I guess I don't have to introduce myself, and I can turn my phone off because I made it here on time. There we go. So yes, I'm Fletcher, work at Heavy Water, and now that we have that out of the way, Test Kitchen, right? So if you're here for Test Kitchen, good. If not, there are a lot of other good talks that I'm going to miss too. So for our time together today, what I want to do is give people that haven't seen or heard about Test Kitchen, get a quick intro, so you get sort of a feel for it. And I apologize if it goes through a little fast. I'll have links and stuff later. Then I kind of want to go through some usage patterns, tricks, things that I've picked up and learned, other patterns that, like at Heavy Water, that we've kind of extracted and played with, and then other things from the community. And then finally the future directions and the challenges and like how this thing contorts and twists and changes like every day. And a promise for everybody that these slides may go quickish, we'll see. But I will post them, and I'll try as hard as I can to make sure that everybody that wants to get the content will be able to get the content. But first, I am really excited that we have finally a logo for Test Kitchen. We held a design contest, and that kind of went through. So if you haven't seen it already, this is what we've got. That actually looks pretty darn decent up on a big screen. Yeah, right? And even better for people here, it's in sticker form too, and they kind of look like this. So I have a few. I know there's a couple other people from Heavy Water here who have some as well. I heard Seth Vargo has some, so hopefully everybody that wants some can get some. And then you can explain to people what this crazy sticker is all about. First, as an intro for people who haven't seen Test Kitchen before, this is RFE. This is Rapid Fire Edition. This is a lot to digest, so I don't expect people to even understand this sentence. But it's basically, Test Kitchen is a harness tool that helps you run chef code on some operating systems, on some platforms in isolation. So there's a few goals that kind of went into this tool, and kind of how I think about sort of its place in the world is when I'm using something like this, I want it to be about as simple workflow as I can get away with, something I don't have to think about too much. We went with more of a declarative static configuration. So this is this like YAML file. For people who haven't seen it, you'll see some examples. So you're not going to see much Ruby code that sets this up. The idea was to see how far we could go to describe sort of like the testing setup in a way that didn't necessarily involve programming to do it. That may have drawbacks and positive benefits. We'll see. It favors speed in development. That was the main reason for doing it, is because I really don't want to waste time waiting for things to converge for like 2 hours and I forget what's going on. But having said that, it does try to optimize for your code that's running on those remote boxes to be fresh and current. So there are some things that people run into in Test Kitchen, like, well, it's kind of doing silly things like it's deleting all that chef code and then it's being re-uploaded. And this is the idea that that might be slower, but I would rather not deal with caching problems and that kind of thing. Like when I like do the chef run, I want to make sure it's like what I had on my workstation. Test Kitchen also has a decoupled plugin architecture. This helps the core kind of stay small. Future interesting ideas are like easy to kind of plug in, and I don't have to come up with all the interesting ways to use Test Kitchen. People can plug in their own drivers if they want to be like spinning stuff up on clouds that either I've heard of and haven't written something for, or ones that I've never even heard for. Maybe they're like internal. So for the sort of Test Kitchen lexicon, the kind of terms that keep coming up, again, this is another big sentence that you guys don't have to internalize whatsoever, but I tried to get all the words out there. So Test Kitchen converges, and it uses provisioners to do that. It can run specific test suites on these like target platforms, and we'd call those running platforms instances, and we use drivers to do it. So what does all that mean? When we're talking about a platform, you can think like an operating system or a target environment. So it might not be an operating system. This is, I guess, the first example of what part of a kitchen YAML file would look like. So it's kind of like JSON, but not exactly. So we've got basically an array of 3 platforms. So there's Ubuntu and CentOS, and the third one is the same version of Ubuntu, but we want to just test Chef 10 on it versus maybe the current Chef. So you can kind of stretch the meaning of platform to be kind of what you need it to be. The suites for Test Kitchen, you can think of that in the Chef context as this is just like a Chef config. It's like a run list, node attributes. It's what makes your setup unique. So as an example, we've got 3 suites here. One that's sort of looking at the client library install, another one that's dealing with just being a server, and then one that's like a server that's being supervised with run it. And the client libs one, we've basically customized the run list here. So there's one item in the run list and some Chef node attributes. So these would go into like a firstboot.json if you were doing like a bootstrap. That's how you can kind of think about it. And if you have all these platforms and all these suites and you do like a pairwise combination of them, what you get are Test Kitchen instances. So that's really all they are. The 2 ideas put together, auto-named, and the configuration applies sort of to all of them discretely. So if we had those 2 examples and ran kitchen list on the command line, this bear flag just eliminates kind of extra stuff to the list command. So if you just need the list of instances, you can do this. So makes the example a little clearer. So you can see there's like client libs and server, and the platforms are on the right, and they're all like the combinations are there. And how Test Kitchen actually like runs through this stuff is actually mostly up to the drivers right now. It's their job to implement these sort of action events or lifecycle events in an instance. And they're basically like creating the thing kind of out of thin air. So you have an instance. Converging is possibly installing Chef unless it's there, depending what you want. Uploading all your cookbook Chef code bits, and then performing a Chef run. And setup is some housekeeping to help with testing, which is optional if you want to or not. And verify will basically run 1 or more different suites of like post-convergence verification, or you can call them tests. It depends. If tests scare you, just think of them as like a sanity check at the end of a Chef run. And you can treat the Chef run as a black box, and then destroy is destroy. So I guess an example of using another driver, this is using the Docker driver. And for that, we can talk to like a custom TCP socket. And you can see we've dropped in a little bit of ERB. That's an optional thing if you want. Test Kitchen by default will run the YAML files. It'll do like an ERB pass-through, so you can do probably dangerous things or awesome things. It really depends on your use case. So if you hate it, don't use it. If it helps solve a problem, then like use it to death. I've got an example where I'm using it to death later. So, the drivers are basically kind of outside the scope of like the core of Test Kitchen, so they end up being Ruby gems. They're plugins, and most of the simple drivers boil down to like writing 1 Ruby class and implementing a couple methods. So there's a growing body of like decent examples, and it's awesome to just like pick and choose. So like the knife plugin ecosystem where you can just like pick your cloud, we're pretty much there now with Test Kitchen. And the notion of a provisioner, it's a bit of a new idea. This allowed me to think of like Chef Solo versus Chef Zero versus maybe a shell provisioner. If you've used Vagrant, there's kind of some similar parallels there. Since we're at ChefConf, it's the thing that runs your Chef code. That's basically what the provisioner is there for, and that's where the configuration for your Chef stuff would go. There's 2 provisioners with Chef that ship. There's the Chef Solo, which would kind of do what you'd expect, and the Chef Zero that's technically it's doing a Chef client run, and it thinks it's talking to a Chef server, but it's actually talking to a Chef Zero server that's operating just on a different thread, and it has all the code, so it's pretty awesome. And this is what a provisioner block would look like if you want to trick it out and do crazy stuff. So if you want to use Chef Zero, you can do something like this. We've got we're basically pinning a specific version of Chef with this require Chef omnibus if you want. And then the nodes path, we're overriding a default to say, like, I have a directory in my project. It's called nodes. I got a bunch of like JSON files that are our nodes. Use those so that when I do a search, it can go and discover things and do crazy stuff. So, and again, the provisioners are kind of, there is a plugin architecture for it as well. I'm not considering that totally stable at the moment, mostly because there's only been a couple of them, and there's already been a few people in the community who have discovered you can write them. So I'm trying to keep close tabs on that. If you're thinking about it or doing it, let me know. I would like to not break people. When we did the driver revving early, it was easy because I knew who was doing it. So this is like a totally different story now. And kind of expanding on that long sentence, the stuff like after Chef is run, if you want, you can optionally write some tests and then have them be executed to verify some kind of state or sanity about your node. And to do that, it's another kind of plugin library called Busser. It's a tiny little Ruby gem that gets installed on the remote instance. It piggybacks off the Omnibus Chef's Ruby. It doesn't share the gems because that ended up being problematic, so it kind of vendors itself away in like a temp directory by default. And its job is just to prepare the instance to receive a bunch of test files and then execute the test harness on the remote server. And basically, for a much more detailed walkthrough, I would highly recommend that you check out the Getting Started guide on the Test Kitchen site. It's meant to be like a building kind of narrative, working up from like an empty directory and making a git commit in a really simple cookbook, and then dropping in a test, and then expanding, and you end up at the end trying to do a TDD style, like adding a feature and using server spec to drive it. So it was, it's fun. And any feedback I'd love to hear, good or bad. So I want to move into, I guess, more the meat of what I want to talk about, which is a lot of stuff that sadly isn't documented yet, which I would really like to get to. But since you're all here, we can get a few things out of the way, and it'll be recorded, and this will be like extra good pressure for me to get this stuff out in a more formal way. So there's a few ways that we've been using Test Kitchen that wasn't exactly what I had originally intended, but they've been great. So one side effect we found, it's extremely good at finding hidden dependencies in Cookbook or infrastructure code in general. So at Heavy Water in the last month or two, we had this situation. We had a Zookeeper cookbook. We're adding another platform for it. And it turns out like our kind of simple basic use case didn't actually directly install Java. It didn't include a Java cookbook. And it was totally fine on Debian until you go to like CentOS, and all of a sudden, no Java. We may not have noticed that before like adding a new platform, and Test Kitchen basically, like the chef run dying because like there is no Java because no code has existed to do it, because you didn't have your like baseline Java cookbook that actually installed it, and they always pair up. So when you like tease these things apart and run them by themselves, these crazy failure scenarios, they just pop out pretty quickly. Another good use case is if you're maintaining like an upstream or a public community cookbook, or you have two different like usage scenarios. Maybe it's going to be used on Chef Client or Chef Solo, or you're on Solo and you want to move to Client, or vice versa. It can find like these awesome little deals that get like tucked away into cookbooks. In early days when I was doing Solo for everything, like the user's cookbook, say, you get like a little search in there, and you go and run it, and then you get this weird failure that like it can't find your client PIM key. And, like, I don't know what that is. So like in that run, like Chef Client is happy and Solo is really sad. So what you could do instead, there's like lots of different ways to solve this. One is maybe opportunistically look for a chef node attribute, and if it's there, just assume your answer is in there, and otherwise fall back to search. Something like this ends up making Chef Client happy, makes Solo happy, and it makes Chef Client double happy because you can still stick your list of buddies into the node itself, into a role, into an environment, and that would supersede a search. So if you need to like basically nuke the search, that's like a nice way to get around the problem. And another use case is to test chef upgrades. So I don't know if you guys ever experience when things kind of go weird and wrong and you have bad days. Or better still, if maybe new stuff happens and you're really excited because there's new features of stuff, and you come to the point where should I just upgrade and kind of deploy across the fleet? That might be okay. But maybe instead, maybe there's a way we can actually test to see if it's going to fail or not. So with Test Kitchen, you can do that. You just can use the notion of a platform, and the platform is the same operating system, but maybe a different version of Chef. So we've got a version 11 of Chef versus a version of 12. And this particular feature, it's still unreleased in master. It's something I'm looking to get out really quick, because the OmniTruck API lets you use partial versions. So you can say, give me 11.10, or give me 11, or give me the full thing. So probably the next release of Test Kitchen, you'll be able to just say, require Chef Omnibus 11, and you'll get the latest version of 11. Or if the version installed is 11, it'll be good enough, and keep going. So really, Test Kitchen's great to find hidden dependencies and failure all over the place. So that's kind of the takeaway from that. For this fuzzy matching, this is something when I see people starting into Test Kitchen and I see them typing really long instance names and stuff, and it just makes me go crazy, because there is this idea of fuzzy matching. So almost all the kitchen commands support it. This is a direct result of me being lazy and not wanting to type much and not wanting to copy and paste things. So what this means is you can do, kitchen list works for this, so it's a good way to figure this out. So you can run kitchen list with the bear flag. You get all your instances back. That's implicitly saying I want all of them. So that saves you some typing. If you're running all, just leave the word off, and you have less to type, and it's the same end result. You can also give a fully qualified instance name, and you get that one thing back. You can also just go for broke, go a little bit shorter, and say, I just want the Ubuntus. And that works. That'll filter your list down. You can be really lazy when you know 4 only exists on the Ubuntu one. Or maybe I'm testing Ubuntu 14.04 versus 12.04. That would be a problem for this one, but maybe you could do 14 and 12. Or if you want to target all the suites and you want to go across the platforms in your one use case, then just use some partial that's in there. And what's really going on under the covers in Test Kitchen is this argument. It's being passed into Test Kitchen as a Ruby regular expression, which means if you single quote it so the shell doesn't eat it and do weird things, you can write a Ruby regex if you really want to. That's occasionally useful. And really, it's in help, but I find that's something I see people doing, you don't have to do that. You can just type less. So the next section here, I would put out there that I think this is the most important takeaway of the talk. It's the thing that I'm most excited about, which is weird. And it's this. That's it. If you haven't tried this before and you have a project, just give it a try and see what happens. That's it. Well, not really. It was something I had originally put in there to support supporting people when they would have problems, and I need to know what version of Test Kitchen are you using? What's your setup? Do you have a local YAML file you forgot to tell me about that happens to nuke some other thing? It turns out it's super useful just on your own, to debug your own setup or the data merging problem, or if you're writing a new driver and you want to see is the config flowing down the way I expected it to. So it's a nice way to make all this implicit configuration or all these defaults that are lurking around, to make them explicit. And because it's echoing all that config back at you, it ends up being this nice shopping list of all these configuration tunables that you can go and monkey around with and play with. So this is some example output of Kitchen Diagnose. It's also in YAML. It could have been any format. I wanted something that was machine consumable, so I could write some tooling and import some stuff and maybe reproduce somebody's failure case. So timestamp was useful to know how old this was, and the version of Test Kitchen. So this one is presumably something off master, and the list of instances that the config generated for you. When Test Kitchen is like going through its paces and you're doing converge and create and all this stuff. It's keeping track of state in a YAML file under the .kitchen directory. And if there's anything in this state file, it'll basically dump it out there so you can see maybe the host on EC2 or the SSH port, which may or may not be what you expected it to be and that kind of thing. You can see the SSH key is like a fully qualified path, so you know exactly where that lives. It also gives you the configuration that was given to the driver. So this one was a Vagrant driver, and you can see the auto-generated expanded URL that if you don't have this instance, this is where it would go download it from. So this is something you could override if you wanted to. The kitchen root is like the full path to like my project directory, so I know like where all the bits are coming from. This is a provisioner block that's also in there. You can see we're using Chef Solo. There's no node attributes that we gave to it. And there's this like Chef Omnibus URL that is defaulting to what you'd expect, which means you can override it and have Chef use another one. So when the Mavericks release came out of OS X, the OmniTruck API wasn't supporting that particular version, so I just downloaded the script, put it in a gist, modified it, and then pointed Test Kitchen over there for like a couple months, and it worked nice. And then for Busser, there is a little configuration now that you can kind of tune Busser. This may either be totally of interest or you don't care at all. So there is that as well, and you can mess with stuff there. So if you find that you've got 1, 2, 3 of these YAML files and they're all merging on top of each other, and you're like, I don't know what's going on, that's where Kitchen Diagnose comes in handy. There's a loader flag that will output if you have a global config. It'll show you this is the exact file that, like, this is where I found it. It's expanded. Here's all the raw data that I read in. This is my project config. This is where it lives. Same with the local config. So in this case, it didn't find kitchen.local.yaml, so it's empty. And then it shows how Ruby like merged all that stuff together. So what the raw data is that's fed into Test Kitchen. So you can kind of like trace the whole flow of data, because sometimes that can get crazy. And if you want everything in one shot, and what I'm likely to ask if I don't know what's going on is I'll say, could you just run that and maybe scrub it for your secrets, because it'll show you like your AWS keys if you put it in. So like take a look for your secrets, probably scrub that out, and put it up in a gist, and then we can like figure out what's going on. So that's the takeaway, is when you start to get confused or things get weird, this solves so many problems. It's solving my own problems more than support problems even. So, and the Thor subcommands I found out by accident. If it'll also do like kind of partial fuzzy matching, so kitchen diag will work because diagnose is the closest and only match. So that's kind of nice. Saves you a few characters there too. I want to quickly talk about the Chef Zero provisioner. So with John's the kind of mastermind behind this one, which kind of blew my mind. So if you haven't already, thank John. It would be a good time to do that. He is around. This is what he looks like. So Chef Zero, if you haven't used it before or don't know what it is, it's the fakest chef server you'll ever use. It's basically an in-memory one that says, hey, I'm a chef server, but it's running in Ruby, and it might be in a thread. So it's easy to spin up, and it's great for testing. And the Chef Zero provisioner in Test Kitchen is the fakest chef client run you'll ever use, because it's a chef client run, but it's sort of like talking to a service that just spun up for it. And to use it, you just put in a provisioner block and say, I want to use Chef Zero. And that's about it. So the provisioner does, like, it supports everything you'd kind of expect it to support if you need to work with data bags and encrypted secrets and environments and nodes. Roles is about the only thing that's not supported, which is actually not true. I got my role engineer on the back of our heavy water shirts. We're not necessarily role haters, so you can even do roles if you want. And the idea by default is you can create a directory, like a roles directory, in this right place. And then you can put the JSON formatted roles in there. Right now, there's it's basically just a limitation with the way Chef Zero works, that you want to stay away from the Ruby formatted roles and environment files. Just stick to the JSON, and it'll basically all work. And if it's not showing up, and you're like, where's my roles? Kitchen Diagnose will show you your roles path if it found it or not and where it's getting it from. So next, I thought I'd talk a bit about this concurrency thing, that's a bit straighter, but it could have come out in any order. So with Test Kitchen, the main goal was to be as fast as possible in development to just save time and sanity. Originally, it was implemented with this like parallel flag. It actually was using celluloid, which I ended up removing because celluloid's awesome, but it frankly wasn't using enough of it to like warrant the awesome. So it's just using normal Ruby threads now. And you would use it like this. It'll work for like all the normal create, destroy, converge stuff. You got that, and like everything's good, and you got all the crazy rainbows, and you like have no idea what's going on. But if everything comes back clean, then you can just walk away. About 3 weeks after I implemented that, I caught this really awesome talk by Rob Pike and realized I'm actually dealing with concurrency, not parallelism. I named the flag wrong. And someone's going to find out, and they're going to be like, that's wrong. It's concurrency. So ever since then, I've been trying to figure out how do I like rename that without breaking it on people. So it took a little bit of work and a few pull requests from the community, and we now have a concurrency flag, which does exactly the same thing as the parallel flag is. We've just made it work. It's kind of an alias. The problem that people have, though, is like, what if I have 24 instances I want to all run at the same time? That can be a problem if it's on your workstation and it just swaps it into the ground. So now with Test Kitchen, you can give concurrency a number, and it'll keep just a pool of threads, and so you only have 3 instances going at the same time, or 4, or whatever you want. And the joke is on you if you're using it in serial mode, because it's still doing a concurrency of 1, so there's still a thread going on in there. And there's a few different ways you can invoke it. These are the commands that would basically understand and like honor the concurrency flag. So you can just use the shorter -c, and a -c is the same thing as parallel, so it's just like do it all. And I'm hoping to eventually just deprecate the parallel flag because it's the same thing. But the idea with that is there'd probably be a release where it would warn that, hey, you're using the parallel flag, you should probably use concurrency. And then on a major version, then remove it so that it's not going to scare or surprise people. So this just lets you move faster and hopefully get more sleep. So environment variables, there's a few that Test Kitchen will understand. This was in there from the start. You can tell Test Kitchen that I don't really want to have a period. Maybe I just want like my file to look like that. Or as a one-off, if you want to try something else and you don't want to like modify the file, you can just like copy it and modify that. So as long as that environment variable is around for the kitchen process, it'll pick it up and use it. And that was working OK for me until this guy showed up. I know he's not here because he's giving a talk, and it's probably going to be a good talk. This is what Noah looks like. And he asked, like, what about if I wanted to use another like kitchen local file? So his use case was he wanted his CI job or his config to be like a YAML file. And in the CI thing, just use an environment variable to say, like, I want to use that one instead of the local one, so you don't have to commit your local one. You can commit the CI one. And that made an awful lot of sense once he explained what he was trying to do. And so there's also the global file. So we kind of looked at that and decided that was a terrible idea, or not really. Why not just support them all? So you can use this. This might not have the same use case, but at least the solution is symmetrical. It's not like one is special now. And if you find that you've done this and you've exported 3 environment variables, and again, you're very, very confused about what the hell's going on, then Kitchen Diagnose will help you. And really, the takeaway for me is like actually talking to somebody with the real world problem that we can like get some meat around and figure out like what's missing. And in this case, it wasn't very much. Is really nice. It makes me really happy. So, and kind of leading into that, I thought I'd talk for a couple minutes about CI because I'm finding lots of people are doing that. It's kind of what you want to do once you've got like tests going, is you want to like leave that to somebody else to run automatically. And that was the secondary goal for Test Kitchen that I had, that I want to be really easy to drop in for CI, and then proceeded to tell nobody how I intended to do that. So that's what Kitchen Test was originally designed for, and that's what confuses a lot of people, because they'll like do a chef run, they'll be like, cool, and then they'll do Kitchen Test again, which destroys their thing, and they just wanted to test a little change. They're like, this takes forever. And the idea for test, this is what it's doing, is it's just running all these actions together, and the emphasis is on the destroying it at the beginning and then at the end. The idea was you just bring it to existence, you put it through its run, and then you kill it, and then it's gone. So there's a few options to do it. The rake and the Thor tasks, if you have a rake file or a Thor file in your project and you do a kitchen init, it'll add a few lines in to basically give you these tasks, and they would look something like that. The idea for these ones is so that you could run like one instance in one CI job. So again, I'll post this. It's kind of pseudocode anyways. You can kind of think of like the two environment variables at the top as something that would like come into your CI or like your matrix of stuff. So like the test kitchen instance and like the git revision. You can check it out, look for a CI file maybe, and set that, and then just run your rake thing. I'm kind of assuming like bundler is just there. If you happen to have a gem file, then your dependencies just come for the ride. So this would work for hopefully almost any simple cookbook running a single instance. You can do the same thing with the CLI. The sample job ends up looking basically the same. It's just running Kitchen Test instead. And there is a way to use Test Kitchen as a library. Like, there's not actually a lot of Ruby code to do it. That might be weird, but if you were, say, writing a Jenkins plugin and using JRuby to do it, this might be a way to go around doing that. So that hasn't happened yet. If anyone's interested, I'd love to talk about that, though. And this concurrency thing, when you end up having your 24 use cases, this is like, normally you're going to do that, and you're going to get like a crazy pile of stuff, and nothing's going to make sense, and it fails, and you're like, what failed? Like, I don't know how much stuff failed. So originally in my head, the idea around the concurrency mode was that that would be for development. In CI, you would just have the CI like split up all your discrete instances. They would be like a downstream job, so like in your build matrix, because CI tools are great for that kind of concurrency and scheduling parallel execution. So that was kind of the idea I had initially, is just let the CI tool do that and figure out how to schedule all that stuff, because it could fan it out across a whole bunch of workers, and you'll get discrete failures. If all the CentOS ones die, then you know you probably have a problem in the CentOS one, and the Ubuntu branch stuff maybe works OK. So that's kind of my takeaway. That's without really providing any supporting evidence for it, but that's just kind of where I'm coming from. That's why some of this stuff is the way it was. And finally, I'll see if I can get this in time. I did want to talk about HDC, which I call hyperdynamic caching, because it's awesome. This came about when I was doing a talk late last year, and I really wanted to try a live demo just showing some of the Test Kitchen stuff, but that's kind of crazy, and it's scary because the conference Wi-Fi, you never know what you're going to get, even if they're like, yeah, it's going to be awesome. And actually, in Vancouver, it was awesome. So I didn't have anything to worry about, but I did worry. And kind of looking at how to solve this problem, the solution was kind of already in there. There was this HTTP proxy environment variable support, which is basically, in general, it's the best environment variable ever. And it's thanks to this guy who dropped it into Test Kitchen. And I'm like, what is this for? And it took me a while to kind of figure out why he wanted it and to explain it. So if you haven't thanked Adam Jacob, you should do that. This is what he looks like. I believe he's the guy on the left. I've got that on good authority. And I've been staring at it for like 5 minutes to make sure he's on the left. So to set it up, it's a driver concern, so you can just set HTTP proxy. The HTTPS may or may not work in your use case, and you just give it the URL for a caching proxy. It turns out that this particular environment variable, it gets honored by like everything. Like, at least in a like Unix, Linux land, everything will honor this if it's there. So what we end up doing, or what I end up doing on my laptop, is I use the little caching proxy called Polipo. If you've used Squid, it's kind of a similar thing. It's not that hard to install. It's just a homebrew install or an apt-get. And then I just kind of ran it with basically all the dangerous promiscuous flags on so that anybody could like talk to it. Hopefully only locally. It might be good to run a firewall around your workstation. But and then kind of for final gravy, I used Sean Porter's test kitchen or Docker driver and spun up the instances just as Docker containers because it's so nice and it's so fast. And really to set that up at the end of the day, you just use the Docker driver, like gem install the Docker driver, put in your gem file, and then reference the socket. You can see I'm just using an environment variable to go get that thing. And what I really wanted after that worked is I want a way to like turn it on and turn it off. So I kind of started working on this weird little, this is actually a kitchen YAML file, and it's breaking out and doing some Ruby code to check if ports are listening and stuff, and setting a variable at the end. So it's pretty crazy. There's a reason that's not in the core, even though I've been on and off using it like kind of daily. It needs some baking and some ideas. But it is there. I've got the gist here. But the result is, at least for me and a few other people that are using it, is it's fast when you want it to be. So basically, when you are running the Polipo service and the port's available, it'll be like, I'm going to do caching crazy. And when it's not on, it'll be like, that's OK. I won't use any of it. So if you need to like time your chef run or make sure that the cache isn't like the upstream, like it doesn't exist, but it's in your cache. So now like the caching is lying to you. It's not necessarily for the faint of heart, but if you want to try it, right now it's a gist. I'll probably get this someplace a bit more formal and figure out if there is a way to kind of bring it into core, because it is pretty nice. And finally, I think I've got a few minutes. Couple? OK, so I will do this as fast as I can. So the future. These aren't in any priority order, but these are basically things that are on my mind and things that people are asking about. So there are still a few things that are they are the way they are in Test Kitchen based on like the directories you have set up, and there's some lookup strategies. In doing the kitchen diagnose, what I realize is I want like everything to be like have an explicit config default so that kitchen diagnose will show it to you and then you can adjust it. So I still have kind of work where I want to be dropping in a lot more kind of config all over the place so that you can override things and say, my tests live over here because that project structure works better for me. Similar with the Busser plugins, right now there's not a lot of control over even the gem that's being installed remotely, let alone the version. So I want to be able to make that a bit more explicit so you can pin things and maybe use another gem, even though it's like server spec or something like that. Windows seems to be a big one, a nice theme. I'm really excited that there's lots of people who have interest in it as well. Primarily, we're talking about running Windows as a target platform for testing. That's kind of like that's the big hurdle to get over. But I think there's been lots of work out there that lots of problems are being solved. So this may not be as hard as I originally thought. And then making sure that it works really well on Windows as like a workstation. I've heard that some people are just using it, but because I haven't used it yet, I don't want to vouch for it and say like it should be OK. I'd rather be solid. There is a bit of work because of Windows to kind of formalize this idea of a transport. So like I want to talk over SSH to this instance or WinRM or maybe a serial connection or make that a bit more of a first-class citizen that can take some config and you can swap stuff out. I'd like to also firm up the provisioner API in the way that the driver's kind of solidified, because that's still needs a little bit of work. Clustering is still a bit of a big unknown question to this date. I haven't said that I've really solved it or have a concrete idea. It's getting there. So stuff like the demo this morning, I hope that everybody's starting to get ideas about Chef Metal and how that may apply. I actually got some new ideas. There could be ways to use it. So I'm kind of curious to see what other people have to think about that. And for me, it's getting a lot of the actual testing of this testing framework done the way it should have been initially. And this is because this was like a weekend, like, whoops, I wrote a library kind of thing. And I would like the code. The code, I think, largely works for people. but it makes refactoring scary because there's no safety net. So I have been working to make sure that there's reasonable test coverage so that when people add stuff, I know what can be like taken in or not. And I'm probably over time, so I will end it there. I am available here. I believe we can get a time in the Marina room for more questions, and don't hesitate to come up and talk. So thank you.